So Gabriel prepared the following setup, and he placed thin pieces of iron, copper, and plastic sheets between the magnet and the paper clip. Okay, so as you can see, this is a setup like this with the retort stand, and then there's a magnet clamped here. Okay, there's an iron paper clip here that is suspended with a thread attached to it. So what happens is the magnet is actually attracting the iron paper clip. Okay, so the magnetic force can actually pass through this thin piece of material. Okay, so sometimes some materials allow this magnetic force to pass through, while other materials do not allow this magnetic force to pass through. Okay, so let's take a look at this video, which will show you how some materials, how do they interact with magnets. Alright, let's take a look at this video. Okay, so over here, I have a magnet, okay, and I have this piece of material over here. So when I place this material close to the magnet, what happens? It gets attracted by the magnet. Okay, so this shows that this material is actually a magnetic material. Okay, so now this paper clip is attracted to the magnet as well. And as you can see, magnetism can work at a distance. Okay, but when I place this magnetic material in between the paper clip and the magnet, watch what happens. Okay, the paper clip actually falls away. Okay, we look at that again. When I place this magnetic material in between the magnet and paper clip, the paper clip falls away. Okay, so this shows that the magnetism cannot pass through magnetic materials. Alright? Okay, so let's go back to the slides. Okay, so in this case, if this is a magnetic material, okay, the magnetic force will not be able to pass through, so it's actually redirected into the magnetic material, and that's why the paper clip falls away. Okay, now let's look at another video which shows a non-magnetic material. Let's see what happens. Okay, so now I have this video, same setup. I have a magnet. Now I have a piece of plastic. When I place the piece of plastic close to the magnet, as you can see, the magnet is not able to attract it. Okay, so the piece of plastic falls away. Okay, similarly, the paper clip is attracted to the magnet. Magnetism can act at a distance. And when I place the piece of plastic in between the magnet and the paper clip remains suspended. Okay, let's watch that again. So when I place the plastic between the magnet and paper clip, magnetism or magnetic force can actually pass through it to allow the paper clip to still be attracted. Alright, so that's the difference. Okay, so in this case now, if it's a non-magnetic material, the magnetic force can still pass through and it can still act on the iron paper clip. And that's why the iron paper clip remains suspended. Okay, so that's the difference. So these are his observations. He recorded them in this table. When the material is made of iron, the iron paper clip dropped to the floor. Okay, iron is a magnetic material. Okay, let's recap. What are the magnetic materials? C-O-I-N-S. CO is cobalt. I is iron. This is nickel. And this is steel. Okay, so these are magnetic materials. If I place them in between a magnet and a paper clip, the paper clip will fall to the floor. Now, copper. Copper is a non-magnetic material, similar to plastic. Okay, so these two are non-magnetic materials, and as you can see, from the video just now, the iron paperclip remained floating, which means that magnetism can actually pass through non-magnetic materials. Okay, so what can be observed from his experiment? So the magnetic force from the magnet can pass through the plastic and copper sheets, but not the iron sheets. Okay, the plastic and copper sheets are non-magnetic material. The iron sheet is a magnetic material. Okay, so let's recap. Magnetism can actually pass through non-magnetic materials.